Good morning. We will be talking about modeling of mechanical engineering phenomena by Denis Barreto. This is the topic we will talk about. Uh, First, energy balance for the oscillation of the point mass. Second, parametric oscillation. Third, cup oscillation. Cup spring pendulums for oscillation of two couple oscillators, yeah, and normal vibration. This is energy balance for the oscillation of the point mass. Introduction is classical mechanic. The energy balance is the usual law of the motion and agent. In the case of the oscillation of the point mass, we can use energy balance, understand how kinetic and potential energy and the exchange during the motion. Kinetic energy, the kinetic energy of the point mass is gained by the equation Ka equal 1 divided to AB raised to, when n is the mass and v is the velocity of the point mass. Elastic potential energy. The elastic potential energy of the spring I guide by the equation Pa equal 1 divided 2 rise to x, where K is the spring contact and x is the spring deformation. Simple harmonic motion. In the simple harmonic motion, a point mass is a take of the ideal spring and moves back of the phone about a fixed axis. During the oscillation, the point mass move from the one of the other, change its velocity and deformation in the process. Energy balance. During the oscillation, the elastic potential energy is a convert into the kinetic energy and the vice versa. The total mechanic energy is the conservation during the oscillation. Example of the energy balance. At the highest point of the oscillation, the velocity of the mind in the zero and the mechanical energy is the convert into the elastic potential energy. We can see is the graph how the energy and the balance are the rate at different points. Is a P and W as the graph is a oscillator in the 1 point, 2 point. As the point mass moved to the worst to the other end on a spring, the elastic potential energy convert in the kinetic energy, reaching in the maximum value at the lowest point of the oscillation, is at the point line X. Parametric oscillator. Introduction. A parametric oscillation is a system the natural frequency of the oscillation changes what the two do to the some external divide force. This design is the frequency can cause interesting and no intuitive variable in the oscillation. Example of the parametric oscillation. A common example of the parametric oscillation is a shield swing where the natural frequency change of the shield pumps their leg back and forth. The motion of the swing becomes more vigorous as the shield pumping becomes more in the sync with the natural frequency. Math of the parametric oscillation. The math of the parametric oscillation involves Cope differential equation, where the equation governing the motion of the oscillation depend on the external deviating force. This force can come in different forms such as oscillation mass or spring. The resonance is parametric oscillation on the hysteretic effect of parametric oscillation in the can exceeding resonance of frequencies that are not natural frequencies. This is the because natural frequency oscillation changes with time, allowing in the resonance at the different frequencies. Parametric amplification, another interesting effect of the parametric oscillation is the parametric amplification. This is the where at the amplitude on the oscillation increase over time due to the external driving force. Application of the parametric oscillation have application in the variety of field, including in engineering, physical, and biology. In the engineering, they can be used for the single processing amplification, and the biology they can use to the study and the dynamic of population and ecosystem. This is the graph. This is the graph. It does not allow CU oscillation in the pendulum for the amplification force. Stance is the pendulum is um, 1 point is the oscillation. Amplification is in core. Cup oscillation. Cup oscillation system apply important role in physical and technological application. The occupant cause and energy transfer become different oscillation subsystem as many local separation oscillation system are coupled. The oscillation energy can to travel as mechanical wave through the total system without such a coupling on the mechanical waves can develop. In the section, a wide affairs deal with the coupling on point must before we discuss and the more contempt cause of the coupling between extended bodies. Couple spring in the pendulums is a couple spin and the grab oscillation is the ondulation. Couple spring pendule are the classic exam and system of the couple oscillation. The system consists on the multiplets pendule connect by a spring which in the interact with con each other through the motor. Force oscillation of two couple oscillation. With the couple oscillation are the spot and the external periodic force FD FO caused it that the comes on the M1 but makes arid excitation for oscillation due to coupling between M1 and M2. The equation of the motion that become with the mode M1D M2DM is the nets graph. Description the system, a system or ecosystem to couple oscillation may is connected by a spring with the each mass oscillation backup of the force. The motion of the each mass is determined by a station in the spring, the gravity force active, and the external forces station. In the free oscillation after a force, the system of to the coupled oscillation what exhibit free oscillation what at the maze oscillation back and the fourth at the natural frequency. The motion of H Mass is determined by position and motion on the other mass. Force oscillation, when an external force is applied of the system, I can cause the mass oscillation a frequency other their natural frequency. This is the chaos force, the oscillation, and the frequency of the oscillation is determined by the frequency external. Is at the graph in the force is oscillation to force to oscillation to force application. Force oscillation of the two couplers oscillation have application and physical energy and material essence. They can be caused to study and the behavior and the system mechanical substrate and the body on the external vibration. The Kinesol uses the study in the property of the material, which the resonance frequency and the damping factor. Resonant damping factor is example the for oscillation. An example for oscillation in the system to couple oscillation behavior of the breath under the wind law. The wind cause of the breath to vibrate of the expectation frequency match at the natural frequency break of the external force at the system. Normal vibration, normal vibration are the tape and the mechanical vibration at the course on the structure of the system multiplied of the freedom. The characteristic beach of the different oscillation is the natural frequency. There is the freedom of the dove are the independent what are the system name can move. For example, a simple pendulum has of the drift front with a two pendulum has two duplicate. Natural frequency is the natural frequency and the system oscillation is the graph and the oscillation free width of the any external force. H, the freedom system, natural frequency that depend on the stiff and damping. And free vibration is the graph, vibration in different, right? Free vibration when and the system in the mountain allow of the two oscillation free width of any external force. The resulting vibration is combination of the natural frequency and the shapes of the system. And concludes as the mass move from on the spring order, kinetic and potential energy and the chain resulting in continuous oscillation, total conservation of mechanical energy. By understanding the dynamic parametric oscillation, we can and insight into the run of the natural and engineered system. By studying the dynamic of the couple oscillation, we can again insight to the behavior at wide range of the natural energy system. By studying couple spring pendulum, we can insight in the behavior of the range natural and energy system. Force oscillation to the couple oscillation are the common example of the system exhibiting interesting complex behavior. By studying a dynamic of the coupled oscillation, we can in sync to the behavior of the wind run natural energy system. Neural vibration are fundamental concepts in the mechanical and structural engineering. Thank you.